We're going to start notes on 9.2 over parabolas. Okay, and some of this stuff should be familiar because we already did parabolas once this year, but then some of it is going to be extra too. It's going to be new material. So let's read through the notes and then we'll do some examples. The standard form of a vertical parabola is y equals a times x minus h squared plus k. And I'm going to write this down in a table format so it'll be easier for you guys to find the information whenever you're doing your work. If you want to keep it in paragraph form, that's up to you, but you're just going to have to search a little bit more. Okay, so if you have a vertical parabola, the equation is y equals a times x minus h squared plus k. And we've already used these vertical parabolas. If a is a positive number, if it's bigger than 0, then it's going to open up. If a is less than 0, then it's going to open down. If it's negative. Okay, so then we're also going to be working with horizontal parabolas. That equation is x equals a times y minus k squared plus h. So when it's x equals, in parentheses, instead of x minus h, you have y minus k. And then instead of the k being outside the parentheses, the h is outside the parentheses when it's x equals. So that's something that a lot of people mess up on whenever they're working with these. When you have x equals, your h is outside, the k is with the y inside the parentheses. So this one opens horizontally. If a is a positive value, it's going to open to the right. If a is a negative value, it's going to open to the left. Okay, so you do have a vertex on both of these, and actually that's one thing that isn't different. The vertex is going to be HK in that order, whether it's horizontal or vertical. And then we have, I'm going to go through all of this and use the vocabulary, and then when we're done going through the equations, then I will draw a parabola for you and label everything. Okay, so we have your vertex. The next thing is the axis of symmetry, and you guys should remember the axis of symmetry is the line that goes down the middle of the parabola. It cuts it in half. So if you fold the parabola on that line, it's going to be symmetrical. Okay, so for the vertical parabola, your axis of symmetry is x equals whatever the h is. For a horizontal parabola, it's y equals whatever the k value is. It always goes through your vertex. Okay, then you have something called the focus point. And that's inside the parabola, and we'll go over where it is when we're finished here. So when you have a vertical parabola, the focus is the x value is whatever your h is, and then the y value is k plus 1 over 4a. If you have a horizontal parabola, it's h plus 1 over 4a, and whatever your k value is. And then there's a line called the directrix. And for a vertical parabola, the line is y equals k minus 1 over 4a, and it's important that you have the y equals because it is a line. When it's a horizontal parabola, the line is x equals h minus 1 over 4a. So you're using that 1 over 4a more than one time when you're finding parts of a parabola. Okay, then they have something called the latus rectum, which is a segment that goes across the bottom of the parabola. I think that's why they call it the rectum, because it's at the bottom. So the length of that is absolute value of 1 over a in whatever unit of measure they're using. And it's the absolute value because you only measure in positive numbers, right? You don't measure in negative numbers. And that's true for both of those parabolas, whether it's vertical or horizontal. Any questions? Okay, so I want to go over the parts now. I'm going to scoot this up a little bit. You guys ready? Not very far, just a little bit. So for your vertical parabola, you have something like this. And the sides, I tried to make sure that they're going out. They're getting wider as the parabola goes up. I'm just writing the equation down here. Okay, so you have your vertex at the very bottom, and your axis of symmetry goes right through the vertex. Okay, so the two parts that you're not familiar with would be the focus and the directrix. Okay, so your focus is just inside the parabola, and the directrix is a line outside. And that's actually how they get the point on a parabola. Any point on this parabola is going to be the same distance to the focus as it is to the directrix. So those distances are the same. And that's how they get every point on the parabola. You could put a pin here and something representing a pin on your directrix and get a point, and then move it on your directrix to get another point. So the distance from the vertex to a focus is 1 over 4a. So to get your focus, you're going to add that to the y value. To get the directrix, you're going to subtract it, because the distance from the vertex to the directrix is 1 over 4a as well. It's the same distance. And then you have your latus rectum that goes through the focus point parallel to the directrix. And you can use that to get your value for a sometimes. Okay, so then you have a horizontal parabola. And all the parts for a horizontal parabola are really the same. It's just that it's been rotated. So you have your vertex, you have your focus, you have your directrix, which is now a vertical line instead of a horizontal line. You have your axis of symmetry, which now is horizontal instead of vertical. Okay, so all the parts are the same. It's just it's been rotated around 90 degrees. Any questions? Yes.
What's that word next to the lattice rectum? Next to whenever a axis value?
Right there?
At the top, when it says not on the graph. Yeah, like.
That's unit.
Okay.
Right there. Okay, so let's do an example. And the example we're going to start with is above number 1. I don't know why it just didn't get numbered. Is everybody finished with this? It's on page 599 in your book if you need to look in your book. All right, so they're giving us an equation. I'm just going to say it's an example. The equation is y equals 2 times x minus 1 squared plus 3. Okay, so it says give the coordinates of the vertex and the focus, the equations of the axis of symmetry and the directrix, and the direction of the opening. So the first thing you want to do here is determine what set of equations you're going to have to use. And since this is y equals, I know that it's going to be a vertical parabola, right? So I'm going to use all of those equations for a vertical parabola. So the vertex coordinates, HK is going to be 1, 3. The focus coordinates for a vertical parabola is h and then k plus 1 over 4a, whatever that works out to be. So I need to figure out what 1 over 4a is. Okay, so 1 over 4 times 2 is 1 over 8. So to get my y value for the focus, I'm going to take k, which is 3, and add 1 over 8 to it. Okay, and I got to change this so it has a common denominator, and I'm going to wind up with 25 over 8 for my y value for the focus. So the focus is 1, 25 over 8. The next part is to get the equations for the axis of symmetry and the directrix. So your axis of symmetry, when it's vertical parabola, is just x equals h. So this is going to be x equals 1. The directrix is y equals k minus 1 over 4a. So I already know what 1 over 4a is. It's 1 over 8. Now I'm going to take k and subtract 1 over 8. So that's going to be 24 over 8 minus 1 over 8, 23 over 8. So my directrix is y equals 23 over 8. And it's important to have the y equals because it is a line, just like it's important to have x equals for your axis of symmetry because that's a line. Then the last thing they want me to find is the direction of the opening. And since A is positive, it's going to open up.